Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, we'll continue with the topic of multiple regression, and we'll talk about how we partition variation or variability in the multiple regression framework. So by now, we have looked at the smoking example and talked about how to interpret the intercept and slope estimates, but let's talk about the overall variability that we're working with in the model. So essentially, the model we specify says that the year smoking and stress predictor variables determine in some way part of each smoking intensity score. So essentially, subbing in the predictor variable scores into our regression equation will give some predicted smoking score. Now, we talked about how with multiple regression, especially with two predictors, we're now thinking about the plot in terms of a plane, okay, or a regression surface. So substituting in the predictor scores will give us a predicted smoking score that's a point on this regression surface. And the total distance to the overall mean, the grand mean of y, smoking intensity, is determined by the predicted score and leftover variability. So let's take a look at what these plots look like. Essentially, the grand mean is just a flat surface represented by the overall mean of y, which is smoking intensity. And we know that the overall mean of y is 10. So this plane is a flat surface. It's not tilted in any way towards the predictors or away from the predictors, just a flat plane that gives us the mean at 10. Now, total variability is each score minus the mean. And I've showed you these plots before. So essentially what we're looking at are the residuals, or the distance between each score and the mean. And the red bars indicate that that score is falling below the plane, and the green bars indicate that that score is falling above the plane. So you can see y minus, the score of y minus the mean, y bar, is negative or positive. Now, our predicted values are the values that fall along the regression surface. Remember that the regression surface is defined by how our predictors are giving us predicted values on the outcome. So we have run an analysis at this point, and we have the coefficients, the regression coefficients, that we could plug into an equation to get all of the predicted values of y that would be represented in this plane. So the plane is the predicted values of y. And I've shown the formula for the regression, the multiple regression equation here as well. Now, if we think about explained variability, okay, essentially how much variability is being explained by the model, because we're creating this regression surface, the regression surface is representing essentially the alternative model, the alternative predicted model for the alternative hypothesis. And then the grand mean plane is representing the null hypothesis, that there's no effect, no tilt towards years smoking or tilt towards stress. So this is, so the difference between the flat surface or the null surface, the grand mean, and the tilted regression surface plane is the difference between the predicted value and the mean. Okay, so this is the explained variability. It's the distance between the flat plane and the tilted plane. And I've shown here that difference between the predicted value of y, right, that's the regression surface, and the mean, the purple flat surface. Where it's positive, I've stuck in these green bars to show you the distance between the plane and the flat mean surface. And the red ones are for when that difference between the predicted value and the mean is negative. Okay, so the difference in the planes, okay, the distance between the two planes is the explained variability. Now, the leftover residual variability is the score minus the predicted value. And we know that this is the leftover residual variability in 2D plots when we're looking at simple linear regression as well. So this is just the difference between a point and the regression surface, which is giving us all of the predicted values, right? And again, here we have these green bars to show us when the difference between the score and the predicted value is positive, and the difference red for when the difference between the score and the predicted value is negative. So visually, these are the different types of variability that we're working with. So now let's take a look at the regression model and look at how the variability is represented in this model. So essentially, what this equation is showing is that a single observed score is composed of the grand mean, which is the mean of y, the difference between the predicted score for y and the mean of y, which is the influence of all of the independent variables taken together, and then the leftover error variability, okay? And that is the difference or the distance between the observed score and the predicted score. So each of these three planes, or three plots, I'm sorry, is shown in this score decomposition. Next up, we will continue with the topic of partitioning variability in multiple regression.